I get asked all the time, what's the real difference between a good developer and a truly great one? It's usually not about who writes the most code. It's about who can master the code that's the absolute hardest to get right. So today, that's what we're going to do. We're going to tackle how to test the most challenging parts of any modern C# application. So let's just ask that question right out of the gate. You're probably already writing some pretty clean code, you're hitting your deadlines, but what is that next level? What's the thing that really signals to everyone that you've got a senior level mastery of your craft? Well, a lot of the time, the answer is all about building a shield. It's the ability to write these incredibly robust, reliable tests that protect the most critical and, the most complex parts of your application. That's what ensures the whole system just works, day in and day out. And what are those challenges exactly? Well, they usually fall into these three big buckets. First up, you've got asynchronous operations. That's kind of the backbone of any responsive app today. Then you have background jobs. These are the hidden workers doing all the heavy lifting behind the scenes. And finally, external APIs, all those third-party services that our apps totally depend on. I'm telling you, if you can master testing these three, it is a total game changer for your career. Okay, first up, asynchronous code. It's the engine that powers modern C# apps, right? It's handling everything from database calls to API requests. But that power is also its biggest weakness when it comes to testing. This is where so many developers get tripped up. This slide just lays it out perfectly. On the left, that's the common mistake, forgetting the await keyword or even worse, using .result. That isn't just bad practice, my friends, it's a ticking time bomb that will absolutely cause deadlocks in your application. The senior path, on the right, it's simple, but it's completely non-negotiable. Your test method has to be async, and you have to await the call, period. But look, testing the happy path is only half the story. I mean, that's table stakes. What happens when your async method is supposed to fail? A senior developer knows that testing for failure is just as critical as testing for success. You've got to prove your code can handle errors gracefully. So here is the crucial takeaway. This is the big one. For the success case, you await the result. For the failure case, you use assert.throws async to prove that the correct exception got thrown. This isn't just a suggestion. It's the professional standard for truly bulletproof async testing. All right, let's move on to our next challenge, which kind of builds on this. Background jobs. Think about sending a welcome email right after a user signs up. That process happens, well, in the background. It's totally detached from the initial web request. So how on earth do you test something you can't directly see happening? The key here is a complete mental shift. You have to stop thinking about the scheduler, about Hangfire or Quartz or whatever you're using. You don't care how the job was triggered. You only care about the job's behavior. Did it try to call the email service? Did it update the database? That behavior is what you're targeting in your test. And the process is actually a pretty simple three-step. First, you just trigger the job's logic directly in your test. Second, you replace any external services, like that email client, with a mock object, a fake version. And then, step 3, this is the magic part. You use a method called verify to just ask that mock object, hey, was the send email method called with the right user data? This proves the job worked without ever having to send a real email. It's brilliant. All right, our final boss, and maybe the most common challenge of all, taming external APIs. Your app might rely on Stripe for payments, a weather service for data. Whatever it is, these dependencies can be a total nightmare for reliable testing. Here's the core issue. If your unit tests are making real network calls to some external API, they become incredibly slow. They're unreliable. I mean, what happens if that API is down for maintenance when you run your tests? And they are so fragile. What if the API provider changes their data format? This is a major anti-pattern, a huge red flag. So the professional solution is to completely isolate your code from the network. You mock the HTTP client by giving it a fake HTTP handler. This gives you total control. You can literally tell your test, hey, when the code asks for weather data, I want you to pretend the API sent back this exact JSON response. And what's the result? Your tests are lightning fast, they are 100% reliable, and they always produce the same outcome. So we've walked through the three big challenges. Now let's pull it all together into a clear playbook, a set of principles that really guides a senior developer's approach to writing world-class, rock-solid tests. Okay, here are the golden rules that tie everything we've talked about together. You master asynchrony with async and await. You isolate your code by mocking every external dependency. You build resilience by testing for both success and failure. And you validate behavior for those background jobs using verify. This right here is the core of the playbook. Now, on the flip side, here are the traps you need to avoid. Don't fall for that result deadlock. Don't let live APIs make your tests slow and brittle. And please never leave your error handling logic untested by only focusing on that happy path. Now, knowing all this is half the battle. The other half is being able to articulate it clearly when it really matters, like in a technical interview. So let's practice the exact answers that are going to make you stand out. Think of this as your interview cheat sheet. When they ask, how do you test async methods? You say, use async test methods and await all results. For async exceptions, use assert.throws async. Background jobs, mock dependencies and verify calls to confirm behavior. External APIs, mock HTTP client with a fake HTTP handler. And the biggest mistake of all, calling real APIs in unit tests. Those are your gold standard answers. They're clear, they're concise, and they immediately signal senior level thinking. And if you ever need to summarize all of this in one single sentence, your one-line gold answer, this is it. This single statement shows a deep, comprehensive understanding of modern testing principles. It's perfect. And that's the senior playbook. We've covered the theory, we've covered the practice. The only question left is, what are you going to do with it? Think about your current project right now. Which test, which piece of code is going to be the first one you upgrade using these principles?